This is all about heat. What is heat? Are there different types? What does it have to do with refrigeration? Here we can see a bunch of molecules in motion. That's all heat is. Heat is just molecules in motion. As things get hotter, molecules move faster. The greater the difference in heat, the faster the molecules move and the faster the heat will transfer between the objects. Sensible heat. This is heat that can be measured with a thermometer. You can see a pan of water. We put the temperature probe in there and we're measuring the temperature of the water. This is sensible heat. British Thermal Unit, or BTU. It's the amount of heat needed to raise the temperature of 1 pound of water 1 degree Fahrenheit. Here you can see 73 degree water. We put a flame under it, it goes to 74. That was 1 BTU of heat. Latent heat causes a change of state, but there's no change in temperature. Here you can see the water is boiling. The temperature is 212 degrees. If you look closely by the pan, you see the red burner is still on, but the temperature stays the same. Heat transfers in 3 basic ways. Conduction. Heat transfer from molecule to molecule. Here you can see we're touching a piece of ice. It's going to be 32 degrees. Here we're touching a hot pan. You can see that it's over 180 degrees. The counter is 70 degrees. The pan is over 180. There's a greater temperature difference, so the ice will melt faster on the hotter object. There's a bigger temperature difference between the two objects. Another way heat transfers is convection. It's through fluid movement. Here we can see ice cube sitting in water. Here's another ice cube, same size. Right underneath a little waterfall, we have fluid movement. We have this liquid movement there. You see that the ice cube in the water under the fountain is melting quicker. Faster fluid flow, whether liquid or gas, the faster the heat transfer rate. You see the one just sitting in the water didn't melt. Radiant heat. This heat transfers through the air or space and it heats up the objects that it comes in contact with. Here we see the temperature probe. We're measuring the air temperature. It's about 58, 59 degrees. We start getting it closer to this rock. The rock's been absorbing heat and it radiates heat outward. You see it's about 61 degrees. If we start moving it away from there, you'll notice that the temperature drops again. The further away you are from an object, the less heat it can radiate. Refrigeration. This is the process of removing heat from an area that is not wanted and placing it somewhere else. How the refrigeration cycle works. Start out with evaporators. Evaporators absorb heat from the area. They come in all different shapes and sizes. But basically their objective is to absorb heat and put it into the refrigerant. To absorb heat, the evaporator must be cooler than the space that needs to be cooled. Just remember, heat chases cold. When it comes to evaporators, there's 3 basic types. High temperature, which is about 40 degrees, those are for air conditioners. Medium temperature is 20 degrees for refrigerators. Low temperature is 0 or below, that's for freezers. As heat is absorbed into the liquid in the evaporator, the liquid will boil and turn into a vapor. It absorbs latent heat. It's changing states. Evaporators often have fans. The fans cause convection and enhance the heat transfer. After the liquid has been boiled away, any additional heat absorbed will be sensible heat. Sensible heat added to a vapor. Since the evaporator is cooler than the surrounding air, moisture in the air will condense or change from a vapor into a liquid. Dehydration is the process of removing moisture and water vapor. So here we can see a drawing, and over on the left side you'll see that's the evaporator coil. Remember, it's going to absorb heat. As it does, it's going to change it into a vapor. Next is the compressor. These are vapor pumps that move refrigerant through the system. These will change the vapor from a low pressure to a high pressure. Once again, compressors come in all different shapes and sizes. Here's a couple of different ones. We have a cool vapor coming from the evaporator going into the compressor. As it comes out, it'll be a hot vapor. Condensers remove heat from the refrigerant. Vapor is hotter than the surrounding air. As the heat is removed, the refrigerant is condensed back into a liquid. You can see there's a fan. They often use fans to help in convection. Condensers remove both latent heat and sensible heat from the refrigerant. Desuperheat removes sensible heat from a vapor. Removing latent heat from a vapor, changing it from a vapor to a liquid. Subcool means that you're removing sensible heat from the liquid. So these are the three processes done in the condenser as you're removing heat. So as it comes out of the condenser, we have a subcooled hot liquid. Next we have the metering device. It regulates the amount of refrigerant that goes to the evaporator. There's one type, it's a type called a TXV. There's another TXV. So here's the whole system: the evaporator, the compressor, the condenser, and the metering device. I want you to notice everything on the blue side is low pressure and low temperature. Everything on the right side in red is high pressure and high temperature. So as we start, we're going to start at the evaporator. Basically, we have a cool liquid coming in. As it's cooler than the surrounding air, it's going to absorb the heat. As it does, it's going to change the liquid into a vapor. It'll boil away. Then it runs to the compressor. As it goes into the compressor, it's going to pump the refrigerant through the system, and it's going to change from a cold vapor to a hot vapor. From there, it's going to move into the condenser. Remember, the condenser's job is to get rid of heat. As it gets rid of heat, it will desuperheat, it will condense into a liquid, and it will subcool that liquid to a lower temperature. As it comes out, it'll be a hot liquid. From there, it moves into the metering device, which determines how much goes into the evaporator.